Hi everyone, welcome back to my channel. So today I'll be going through P5 WA Science on question number 13. This question is coming from Maris Stella High School. So this question is about water and particularly on this concept called condensation. Okay, so over here, right? So basically what is condensation first? We recap first. Okay, one water vapor from somewhere. Okay, you must tell me where is the source. Okay, and this warm water vapor, right, since it's already warm, so it must be of a higher temperature. Okay, and it will lose heat to a cooler. Okay, so that means this one must be lower temperature. Okay, it can be cooler surrounding air or surface area, and then it condenses into your tiny water droplets. So what's the difference? Okay, so if you lose heat to the cool surface area, right, number one, you will be able to see water droplets on the object. So that means it is it's already huge enough for you to see them as water droplets. So it could be on a glass of cold drinks. It could be on the ice creams themselves, the surface of ice cream packaging. Okay, so we are really talking about, let's say you have a can, the water droplets is here. The water droplets is here. Okay, so when the water vapor lose heat to a cooler surrounding air, it's a very different scenario. Okay, that means the object that you will see, right, is very different. Okay, so you will see it is still made up of water droplets, but they are very, very tiny water droplets. Okay, that remain suspended in the air because their mass is very light. So it will appear as mist, fog, or cloud. So that means, right, the clue is every time when you see these few words, mist, fog, or cloud, okay, it means that the water vapor must have lost heat to a cooler surrounding air, not surface area. Not surface area. Because the product, the outcome that you're looking at, the outcome, okay, the end product you're looking at is mist, fog, or cloud. It is tiny water droplets that remain suspended in air because their mass is very, very light. So with this new understanding, so it's easier for us to tackle this question right now. Okay, so observe mist. So straight away you know mist, it must be a cooler parcel of air. Okay, cooler parcel of air. Okay, so when she open up plastic box containing cold drinks, so the mist only appear when she open up the plastic cover. So which of the following explain how the mist is formed? Okay, let's take a look at number one. Surrounding air condense on the cooler air outside the box. Surrounding air cannot really condense. Air, they are mixture of different gases. So for example, your carbon dioxide, nitrogen, oxygen. Okay, and also as well as your water vapor. Okay, these are this make up air, but in this case it's not very precise because if you say air condense, right, are you talking about carbon dioxide condense, nitrogen condense, oxygen condense? No, right? Because over here we know that the outcome of this condensation is probably your mist. Okay, it makes out your tiny water droplets, not tiny oxygen droplets, not tiny carbon dioxide droplets, neither it is not tiny nitrogen droplets. So in this case, right, it is wrong because it is not the surrounding air that condenses. It's actually your water vapor in the surrounding air. So I'll repeat again, it's your water vapor in the air that condenses, particularly only this. Okay, so carbon dioxide not condensing, as well as nitrogen and oxygen. So when I say this, right, does it mean that carbon dioxide, nitrogen, on oxygen cannot condense? They can condense. They can condense. Okay, and change back into your liquid state. Okay, but the requirement for them to condense naturally is not possible when we are in a room setting, or it is not possible for this gas to condense when you are just opening up the plastic cover containing a cooler drink. It's not possible because the requirement for them to condense is very strict, very high. For example, for nitrogen, for them to condense, you probably need to reach a temperature of, okay, maybe negative 197 degrees Celsius, approximately there, or maybe 190 plus, okay, for them to condense. Oxygen and carbon dioxide, they also can, but the requirement is very strict. Okay? It's not possible in a daily life scenario for you to observe this condensation of these gases, okay, in this case. Okay? So number one, strictly wrong. So water vapor from the surrounding air lose heat to the cooler drink. Is this correct? This is actually wrong, because we are talking about the condensation on the cooler drink. That means we are talking about the condensation over here. Okay, so this is wrong. So because the outcome with the observation that we make, right, is the mist. So that's why we say that this is wrong. But will this be observed in this scenario? Yes, this will be observed. Observable. It's just that the picture never show you the water droplets over here. So this is wrong in this context, because this is not how the mist form. But it is correct because the water vapor in the air, when it came to contact with this cooler surface area, it will still lose heat, condense to become your tiny water droplets on the surface of the drinks. So this may be wrong, but this is observable in a real world scenario. Okay, when you are actually doing these actions. Okay, water vapor from the box loses heat to the warmer surrounding air. This is not possible because the water vapor in the box, right? The water vapor in the box will have been of a much lower temperature. Okay, and it cannot lose heat because it cannot lose heat. Therefore, it should not be how the mist is formed. Okay, the water vapor, there is indeed water vapor, but it will not lose heat to the warmer surrounding air. It will gain heat from the warmer surrounding air in fact, and because of that, it will not form mist. Okay, so basically this three the source of water vapor is wrong. The source of it is wrong. It's not the water vapor from the box itself. It's actually from outside the box. Okay, so let's start with the last part. The last part is indeed must be correct. Water vapor from the surrounding. Okay, that's correct. Water vapor outside here, outside the box, condenses on the cooler air outside the box. Yes, when you open up, right, the air, right, inside actually will start to escape, but the air inside escape out of the box, right, is actually way much cooler. Okay, way much cooler, because over here, right, this one contain cold drink. The air inside the box must have lose heat to a cold drink. Temperature drop. Okay, when temperature drop, okay, this cooler air that's outside, meet with this warm water vapor, it will lose heat and condense, and then it will form into your tiny water droplets that remain suspended in the air in what we observe as mist. Okay, on this portion. Okay, so that's why number 4 is the correct answer. Okay, so in this case, right, the correct answer that how the mist is formed is actually 4. Okay, but if you will ask me again this question, okay, what can you observe? Okay, in a real world setting, you will observe mist coming up. Yes, 4 is correct. You will also observe water droplets on the surface of the can. So 2 and 4 is observable, but how the mist form is actually 4. So 2 and 4 is actually very, very close, because a lot of people will make these mistakes of choosing 2. But 4 is the one that how the mist is formed. Okay? If the question asks, explain how the water droplets on the can is formed, then 2 is correct. Okay? But the question asks you how the mist, okay, which is this part over here. This part over here, how is it formed? So 4 must be correct. Okay? It's the cooler air that the warm water vapor lose heat to, not the cooler surface of the drinks, which is this part over here, not here. Okay, so with that, I'll leave this over here. Thank you very much.